Bueno, continuamos con nuestras presentaciones del bloque de hoy y vamos a pasar a la siguiente charla, ¿vale? Que va a ser la charla de Indranil Ghosh. Indranil es un estudiante de doctorado de matemática aplicada de la Universidad de Massey University, ¿vale? Y su investigación trata sobre sistemas dinámicos y caos robustos. Es un tema súper interesante. Él trabaja con Python y R y trata, pues, sus intereses son análisis de datos, software libre, ciencia computacional y, atención, que sus intereses también son el fútbol. ¿Vale? Entonces, claro, lo que nos va a contar Indranil ahora es cómo podemos utilizar datos de notebooks de Jupyter para acceder y visualizar datos de fútbol. Un tema interesante y seguro que veremos cómo parece que el fútbol es algo a priori simple, pero tiene una gran cantidad de datos que pueden ser analizados y extraer un montón de información muy relevante y muy interesante. Bueno, sin más, os dejamos la presentación de Indranil, ¿vale?
One. So I am Indranil Ghosh from the School of Fundamental Sciences, Massey University. Uh, Today I'm going to talk about an introduction to hands-on football data analysis with the help of Python. And this is my Twitter handle. You can find me here. This is my website. Go check it out. And thanks PyConES community for giving me this opportunity to speak at this prestigious conference. And I'm really glad that I am here to present my topic with you all. And today I'm going to cover some of the things. So I'm going to teach how to get open access event data from like StatsBomb using the package StatsBomb.py. Then how to draw a soccer pitch using MPL soccer package, and then how to visualize a pass network and use networkx module to analyze the pass network, and how to use computational geometric concepts like convex cells, Voronoi diagrams, and Delino triangulations using Python package scipy.spatial on the football event or tracking data. I will, as I'm given 20 minutes to present this topic, I will give an overview of the things, and if you want to go in depth, I will provide the link to my blog, and I will also provide all the information about the resources that I used to learn these topics, and you can follow on from there. So as for any other package, like we use pip to install StatsBomb.py, and just go before for using open data from StatsBomb, go through their term. Make sure to go through their terms and conditions from StatsBomb, and after we download or pip install the StatsBomb.py package, we import the package. Then we use NumPy and Pandas package too, and we next get access to the competitions dataset, and for that we use sb.competitions, and all the informations about these are provided in StatsBomb's GitHub repo. Just go through them, and after we get the dataset, the comp dataset looks like this. So it has competition ID, season ID, the country name, the competition name, the competition gender, season name, match updated, and match available. Here the competition ID and season ID both will be used together. Both will be used as unique ID to get the event data. So here we can so here for competition ID 16 and season ID 4, the continent name actually is Europe, and it was a Champions League game, and it was on 2018-19. So we can use this information to get the data. So we use competition ID 16 and season ID 1, and here the season was 2017-18, and we can use them. As I said here, in mat equals to sb.matches, we use competition ID 16 and season ID as 1, and the dataset mat, and we'll store the data as the dataset mat, and it looks like this. It has a match ID, a 18245, a match date, the kickoff time, and so on. So it was a match between Real Madrid and Liverpool, which Real Madrid won 3-1 3-1 against Liverpool, and it was a final match. And you can use again this match ID to get the event data. So we will do that. And this is the events dataset, the open dataset called events, and it has different rows that you can different columns that you can see here, and these are all the column names. And as we have now been able to collect the event data, we will now see how to use MPL Soccer package to draw a football pitch. We can so it was developed by Anmol Durgapal and Andrew Rawlinson. Make sure to follow them. So we will again use pip to install the MPL Soccer package. So we will import matplotlib and the MPL Soccer and from MPL Soccer.pitch we'll import the pitch class with the capital P, and then we can draw the pitches using the pitch function. Here you can set the pitch color and other parameters to get a beautiful pitch like this. Here we see the x-axis ranges from 0 to 120 and y-axis ranges from 80 to 0, and it's by default it's a statsbomb type field, but if you want you can change it to other types. You can also change the color and set to black, and if you want you can have other types of fields provided, like of opta, trackab, skill corner, y scout, and so on. Okay, so for here I set the pitch type to be UEFA, and here the x-axis ranges from 0 to 100 and y-axis ranges from 0 to 70. And you can also set, like, change the field orientation to vertical. You can change the field orientation to half. And now that we have used MPL Soccer to draw football pitches, we can next use this information to events information, the dataset events, and the MPL Soccer package to draw a path network, like to create a path network visualization. And after that we can use networkx Python package for the analysis purpose. So as I said, I will not go through all the details of the code, but if you want you can either go through the YouTube tutorial by Mackay Jones, or you can read my blog. Both the links are given here, and using the code given here in this link by MPL Soccer, we will use this code to generate the path network. So here we have collected the player informations, like their ID, their name, and their positions, like whether goalkeeper and their position ID and their jersey number. So these are important to collect. Same for Liverpool. And from the events dataset, we will extract the relevant columns for our path network analysis purposes. And these are the columns that we will be using: minute, second, team, type, location, pass and location, pass outcome, and player. And these are the first 10 rows of the events PN data frame. Like we have minute, second, team, type, location, pass and location, pass outcome, and player. As we're only interested in the pass network generation, we'll filter the datasets by keeping only those rows where type is set to pass. So we do that. And these are the renewed datasets with only type as set to pass. And then we will replace the player names with the jersey numbers. But I have skipped most of the codes, but if you want, you can again go through the blog, or like go through my blog, or like listen to Mackay Jones tutorial. So here, pass real new. This is the ultimate dataset that we will be creating and using to generate the visualization, network visualization. Okay, so it has the pass maker jersey number, the pass receiver's jersey number, the number of passes made by the pass maker, the x coordinate and the y coordinate of the average x coordinate and the y coordinate of the pass maker for that particular game of this particular team. And same for so this is the total count of passes made by the pass maker, and same for pass receiver. Okay, so these are the count value is actually used for weights of the edges that we'll draw in the pass in the network. Same for Liverpool. And as you can see here, I used a pitch.arrows function and the pitch.arrows function to draw the edges with arrows. So the arrows indicate the direction of the pass made, and the thickness indicate the counts of the passes, and the nodes indicate the average locations of the players. And so this is for Real Madrid against Liverpool, and this is for Liverpool against Real Madrid from the same match. So now we can use NetworkX package to do some complex network analysis. So for this we only need the pass maker, pass receiver, and number of passes columns, because for now we are not interested in the average locations of the players, but only on the like pass maker, the pass receiver, and the weight that gives the number of passes. The nx.digraph function from NetworkX. So digraph actually means directed graphs, as this is a directed graph. And again here, this graph is isomorphic to the graph that I showed you that was generated on the field. But here we are not interested on the locations of the nodes, so it can be anywhere. But the edges denote the number of the arrows denote the direction of the pass made, and the thickness of the edges denote the weights, like the total number of passes made from one player to other. So that's what it is, like the previous graph. Same for Liverpool. Then we can calculate the degrees of the nodes along with their in degrees and out degrees. So degrees means the total number of passes a player was involved in the whole game. The in degrees denote the number of passes received, and the out degrees denote the number of passes given. And so we can use nx.degree function for this. And this is the histogram plot for each and every player's degrees for Real Madrid against Liverpool. We can do the same for Liverpool's players too. We can do the same thing for in degrees and out degrees by using the in.degree function. We can also generate the adjacency matrices, Liverpool's and Real Madrid's graphs. We work on a metric that focuses on the geodesic distance between two player nodes in a graph. So for this, we only just instead of using the weight, the previous weight, we just use the inverse of the weight, so 1 by that particular weight, and then we generate the graphs in the same way as we did before. And same for Real Madrid and for Liverpool. Now using the modified graphs, we can calculate the all pair shortest paths between the nodes for both the teams, and we can use the nx.shortest path function, and where the weight is the renewed weight, the new weight. And suppose we want to calculate the shortest path from the goalkeeper Keylor Navas to Cristiano Ronaldo during that match in 2017-18, and we can just write print this real 1 to 7, and this will give the path. So from the goalkeeper you pass, if it was passed to Ramos, and from Ramos to the player with jersey number 12, I think it was Marcelo, and from Marcelo to Cristiano Ronaldo, then it would have been the optimum path. So yeah, it was Marcelo. So this seems like a good post-match analysis tool. I got this might look like a crude metric, but we can actually build on this. So I got this idea after discussing with a person named Sarad Babu. So we can do the same thing for Liverpool. We can calculate the eccentricity of each and every nodes. One for Real Madrid and one for Liverpool. We can also calculate the average eccentricities. So they tell us that how far the furthest player node from P is positioned in the pass network. So we can also calculate the average clustering coefficient of a particular team. And the average clustering coefficient lies in the range 0 to 1, where a value of 0 denotes the fact that none of the nodes are connected to each other, and the value of 1 denotes a click. All the nodes are connected to all the other nodes. So here, this value was bigger for Liverpool compared to that of Real Madrid. We can also compute the centrality of the players. We will use the betweenness centrality, and this supposedly gives us the most important player from a particular team in that match. So for Real Madrid, it was the player 14 with jersey number 14, and it was Casemiro. And for Liverpool, it was Henderson. Sorry, it was Milner with jersey number 7. Next, we focus on visualizing convex hulls from players' events data. So we jump into complex geometry, we jump into computational geometric concepts. And if you want to study more about convex cells, just go through the Wikipedia article, or you can just go through the slides. We'll use the SciPy package to calculate the convex cells of the players. So what we do, we will use these columns from the events dataset. So team, location, type, and player, and we will here only set the type to either pass or shot, and this will give us the locations of the players from where the shot or the pass was made. And we will separate this dataset, one for Real Madrid and one for Liverpool. So one for Real Madrid and one for Liverpool, and these are the names of the players. And then we will only focus on a particular player and find out his convex hull, from the locations where he either made a pass or took a shot. So here we'll focus on Toni Kroos. So here we see the type is pass, and the player has been set to Toni Kroos, and his location X and location Y is also given here, denoting the locations from where either the pass was made or the shot was taken. We can also, before computing and visualizing the convex hull, it's a good practice to discard the outliers from the datasets. So actually, Mackay Jones, he uses the Z score, but we can also use interquartile range. So I tried this here. So here from the whisker plots, we can understand which are the outliers, and we can discard them by calculating the quartiles, the interquartile range, and the minimum and the maximum values. Okay, so that's what we do here. We calculate the upper and the lower bound, and then we drop the values which are outliers, and then we collect all these points and from the two columns as a 2D matrix, and then which will be used to draw the convex hull using the convex hull function from scipy.spatial. That's what we do here. Let me show you the convex hull for Toni Kroos. So this is what it looks like, and we can draw the convex hulls for each for other players too from either of the teams. So these are for Rafael Varane, Luka Modric, Dani Carvajal, and so on. Then we can actually download the tracking data using the mplsoccer.statsbomb module, and again we'll use the code given in MPL Soccer's documentation to how to do that, to download the tracking data. So tracking data is actually the GPS data given in a particular time, okay, from the match. So this is what the event and the tracking data sets look like. Tracking head and tracking tail. So if we look closely into the tracking dataset, we understand the column ID represents the unique ID for a short freeze frame. So from a particular short freeze frame gives you the idea about the locations of the players at that particular time from that match. So looking at the player name column, we need to add a column team to the tracking dataset, giving us information about which team the shot taker belongs to, and that we can do. And then we will only extract the relevant columns: ID, player name, X, Y, and team. And this is the particular ID that we will use, which gives the so this particular ID gives the information about a particular freeze frame. Okay. So we'll again use a particular way to collect the jersey numbers of the players and store it in the data set as it's given here. So we can see for Isco, the jersey number was 22, and he belongs to Spain, and his player ID is this. So we can actually use this to set the jersey numbers. We store them as a dictionary. Same for Liverpool. And these are here we have collected all the unique freeze frame IDs. So let us now filter the dataset by using this short ID. Select a particular value from ID column. That's what we do here. And so this is we see that here all the ID columns values all look same for each and every row. And yeah. So we will now compute the Delino triangulations. So again, if you want to learn more about Delino triangulations, go through the Wikipedia page. It's a very good resource. We also need to import Delino from scipy.spatial to get the idea, to understand how to use it. And next, let us separate the data filtered for the teams. For one for Real Madrid and one for Liverpool. And then we are going to build the Delino triangulation similar to as we did for convex cells. We'll first convert the locations of the players into a 2D matrix. Then we can compute the triangulations. Let me directly go there. Yeah, so using the triplot function, and this is what it looks like. Okay. So the red nodes indicates locations of Liverpool's players, and the white nodes indicate the Real Madrid's players, and the black lines indicate the direct links between the players from a particular team at a particular moment, forming the Delino triangulations, as called pus triangulations, also called pus triangulations. So in the book Soccermatics by Dr. Sumter, he mentions that these lines have two useful indications. First, they portray the availability of passes among players from a particular team, and second, they also indicate the no man's lines for players from the opposite team. Meaning, if an opposition player is at that location linking the lines, then they are at a disadvantage. So that's actually useful for analysis. And then we can also calculate the Voronoi diagrams, which is actually the dual of the Delino triangulation. So for computing the Voronoi diagrams, again we use we first import the Voronoi class and the Voronoi plot 2D class to plot the diagrams on a page. So that's what we do here. So this is what the Voronoi diagram looks like. The Voronoi diagrams give us the zones of each and every player on that pitch at a particular moment by breaking the pitch into distinct regions, as we can see here, and belonging to the players, indicating the field coverage of each player at that particular moment. So this completes my talk. Thank you. Go to these references. The book Soccermatics by Dr. David Sumter, the Friends of Teching YouTube channel managed by Dr. Sumter, and obviously the YouTube channel for soccer data analysis by Mackay Jones, the book Graph Theory and Complex Networks by Dr. Martin Van Steen, and last but not least, FC Python blog. Again, this is the end. Thank you. Wear masks, get fully vaccinated, and stay safe. Thank you.
Okay, thank you very much, Indranil. I'm going to put you online. Okay.
Hi.
How are you doing?
Yeah, I'm fine.
Okay, thank you very much for your presentation. Very interesting one. A lot of data, a lot of examples, a lot of interesting packages, even source code. We love your presentation.
Thank you.
Okay, we are going to start the questions. By now, there is no question in the channel, but I have some questions. I'm going to make the question first in Spanish and then in English. Me gustaría saber si esto es parte de tu tesis y si tienes alguna referencia ya publicada que podamos leer, porque es un tema muy interesante. Y la segunda pregunta que voy a hacerte es si algún equipo de fútbol ya ha contactado contigo para que le hagas algún análisis. Okay, now the same question in English. Do you have any reference already published of your work? Is that for your thesis or something like that?
No, it was like a hobby project. So as I said, like I started
Okay.
reading this book by Dr. David Sumter, and also the YouTube channel by Mackay Jones. And there is another blog called FC Python. So these three are the main resources that I found very interesting. So I learned from most of the things I learned from this, and then I wrote a blog actually. So there is a blog that I'm currently maintaining. So yeah, that's it.
Oh, that's great, that's great.
Yeah.
Indranil nos cuenta que es un proyecto como un hobby y que tiene el blog que nos ha comentado, lo mantiene también él y es después de leer estas referencias y estas ideas que lo mantiene, podéis visitarlo. And the other question, any football team has contacted with you to make some analysis or something like that?
For now, no. Like, but I hope that I can work in football data analysis in my future. So let's see. Yeah.
Dice que todavía no, pero que espera que en un futuro algún equipo contacte con él. Yo creo que la verdad que es una idea muy buena, muy completa y fijaos la de información que hay en las redes. I'm saying that this is a very good idea and there is a lot of information, there is a lot of math in this data. So this is a very complex data to analyze and get relevant information.
Actually, this data set, the open data set that's provided by StatsBomb, it's very rich. So you can do a lot of studies with StatsBomb data set. There are other providers too, but I am not aware of them so much. But this, I mostly work on work with the StatsBomb open data. So yeah, most of the analysis can be done with this data. So I think it's very rich actually. Yeah.
Indranil nos cuenta que el dataset que él ha usado, el de StatBomb, es muy completo y que se puede utilizar para hacer aplicarle muchos algoritmos de análisis y demás. Vamos a ver si... Clara is asking in the Discord that is this a project you did in the past or are you still working on this?
I started doing this during March this year. It's as I said, it's actually a blog that I'm maintaining. I will post the link to the blog. But as I get more ideas, I will start including those, working on those in the blog. So let's see. Yeah, that's the plan actually.
Yeah. That's great. Indranil nos cuenta que empezó en marzo, pero que sigue teniendo muchas ideas y las está publicando en su blog. Así que nos invita a que lo visitemos. Bueno, okay, so thank you very much, Indranil. A very interesting presentation. I actually learned a lot about a lot of packages, a lot of mathematical concepts I didn't knew. So I took a lot of notes.
Thank you.
Well, just a last question because we are just in time. But Miguel Frasquet asking YouTube, StatsBomb data is real time? We can match it, or you can use only historical data?
Real time, I think by real time data they mean GPS data. Is that so? Like if they are talking about GPS data, I think they also provide GPS data, and I think real time data is also provided. But if you want more data, I think you have to get the licensed data, so you have to pay for that. I think that answers the question, but. Yeah.
Okay, nos dice que hay parte de datos, pero que si queréis datos en tiempo real y más completos hay que pagar. Okay, so I think we are just on time for the next presentation. Thank you very much, Indranil, la gente que está haciendo preguntas, podéis seguir preguntándole en el canal de Discord y él puede contestar las preguntas después. You will receive some other questions in the
Sure.
Discord channel, so you can answer after this presentation.
Awesome.
Okay,
Yeah,
so
thanks.
thank you very much, Indranil.
Thank you so much, Pablo. Yeah.
Bye.
Bye.